Hello, my name is Shinu Park. I participated in 2014 Summer Research and Engineering program at the University of Michigan. I worked with Professor Goldburn, the Director of Self Materials Research Lab, and worked closely with Elissa Skorbosta, a PhD candidate. This summer, I did research on shape memory polymer, also known as SMP. But let's go downstairs to the lab to further discuss about my experience in short programming. The shape memory polymer is a material that has both glassy and rubbery states. However, it does not show both properties at the same time. There is a temperature which divides the two states. It is called a glass transition temperature. The shape memory polymer appears to be glassy, in other words, stiff like a plastic below the glass transition temperature. On the other hand, it is rubbery above the glass transition temperature. The temperature was measured to be approximately 60 degrees Celsius for our samples. Nevertheless, the temperature does vary according to fabrication processes. Let's watch a video that demonstrates this effect more apparently. Okay, this is a SMP sample at room temperature. It is just like a regular plastic. It is quite stiff, hence I can't really bend or twist at this stage. Simply, I cannot deform this unless I apply a large force. I will now put this sample into oven. The temperature is now pointing at 90 degrees Celsius, which is approximately 30 degrees Celsius higher than the glass transition temperature. It takes about 15 seconds for it to be heated up. We would see the shape memory polymer effect soon. Now I will pull out the sample from the oven. It is now bending and twisting unlike a regular plastic. Currently, it is at glassy state. I'll try to make a flower shape like this. Hold it for a while for it to cool down. When it reaches temperature below the transition temperature, this shape will remain constant. It maintains this shape at room temperature. It is not returning to the original shape. I'll try to deform it with a small force. But I can't really bend it because it is now at glassy state. It is not rubbery anymore. This appears to be its permanent shape when it was fabricated. Now I'll put this back into the oven. We should observe this sample returning to the permanent shape that was demonstrated in the beginning of the video. If you look closely in the oven, the sample is now returning to the permanent shape. This is fast-forwarded by 3 times, and the real time of this event took about 30 seconds. Okay, now it is back to its permanent state. Therefore, it is flat. I'll pull out the sample. It is still above its glass transition temperature, hence it is rubbery and flexible. I'll try to hold it flat so that I can show you the property demonstrated in the beginning of the video again. It is now stiff and glassy like a regular plastic. This sample has returned to the initial state. Despite this great property, there requires more study on the response time of the shape memory polymers. The transition from glassy state to rubbery state and vice versa requires about 10 to 30 seconds, and sometimes even more. This is a significant amount of time delay compared to electric signals, hydraulics, etc. Back to my research experience, we use Instron Electro Plus E1000 to perform tensile tests on this material. We have obtained data, and now we need more time to further analyze its property. Here is a video of the testing. The sample appears in this video is ASTM D638 Class 5. It has specific shape and dimension used for tensile tests. The sample in the video is stretching at 0.1 mm per second. The force and position obtained from this testing are plotted onto stress and strain curve. We will obtain more data and further analyze the property of the SMP and SMP composites in coming fall. Wow, I have learned lots of stuff this summer. Hopefully, I could have another great experience next year as well. In conclusion, I really appreciate Professor Goldberg, Melissa, and faculty members and staffs of 2014 Summer Undergraduate Research and Engineering Programs. Thank you for watching. Bye-bye.